Okay, so I think we finished off task 4 last time. So we're supposed to start on task 5 this time. I just have to check a little bit. The tech guys have been around, they've been switching around computers, and some of the computers aren't working properly because there's been a Windows update that's screwed up something. So if you're sitting at a computer and you can't get the Mentor to work properly, just switch computer. So since they've switched the computer at the front here also, I don't have my usual old projects up in the list here. So I'm going to have to press the browse button to find all of my projects on the H drive. So I go into my computer, open the H drive, and my lecture folder. And then I'm just going to check task 4 to see that we were done with it. Yeah, that was a complete drawing. So then we will start anew on task 5. So we'll create a new project, single user project, create the folder on the H drive. Practice task 5B. And I switch the project name to practice task 5B. And I finish off the project. Then I just double check that it has the black check mark beside it. And press done. So then I'm in on the new project here, and we're going to start a new file. And we have to remember to open up the metric folder and choose the standard millimeters.ipt part. So the goal today is to finish both task 5 and task 6, so that next week we can start on task 7, which will involve assemblies, so that we can start learning that. So we'll start off by creating a new sketch. I'll place it on the horizontal plane as I usually do. And I'll start off with a rectangle, but I don't want one going from corner to corner. I'll choose the option where I start from the center of the rectangle. So I open up the drop-down menu, and I find the one named 2-point center. And when we look at the tooltip, we see that the first point is the center and the second point is one of the corners. So click that one, and I attach the center of my rectangle to the center of my coordinate system. I just pull it loosely up here because I'm going to write in all of the dimensions. So for the height dimension here, I want 90 millimeters. And once I've written in 90 there, I'm going to hit the tab button on my keyboard, and then I get the padlock, so that I know that this dimension has now been locked to 90 degrees. And then the other dimension doesn't show all that well now, so I'm going to zoom out a bit. The other dimension is the width of my rectangle, and that's supposed to be 60. And again, I hit the tab button in order to get the padlock beside it, because then I know that it's locked in at that dimension. So when I either click my mouse button or click enter on the keyboard now, then we see that it's placed the rectangle and it's fully constrained because everything is dark blue. So what we could have done now was to create the parts in I'm using the wrong, let's see here. Yeah, I'm looking at the wrong drawing, so I have the wrong dimensions here. Let's see, it's 45 on the height, and it's, was it 35? 35 on the width. 35, not 31. So there we have it. Now what we're going to do is to also create the square hole in the middle of this part. So I'm going to zoom in a bit here. And I create another one of the rectangles where I put the center point first. And I again put the center point in the middle of my first rectangle. And now I need to set the dimensions of this one. And for the hole itself, it's supposed to be 11 millimeters wide and 11 millimeters high. So that's going to be a perfect square. So 11 and 11, I use the tab button to lock off the dimensions. And then I press enter. So now I can finish my sketch and extrude the plate. So choose the extrude function. And now I have two different rectangles to choose from. So either the square in the middle or the rectangle on the outside. And I only want the rectangle on the outside to be extruded. So I want it to be hollow in the middle. And this one is going to be 8 millimeters thick. And then we're going to create this part that's jutting out from the top of it. So we're going to create a new sketch, and we'll place it on top of the part we've already created. And we'll use the project geometry function. Because then when we click on the part, we get these yellow lines all along the outline of the part. And then again we choose the rectangle option where we put the center point in first. So the rectangle. We attach it to the center of our sketch. And we set it to be 15 millimeters. So it's going to be 15 millimeters on both dimensions. So this one is also going to be a perfect square. 15 and 15, press enter, and we've placed it. And if we want to do an extrude now, Inventor is going to treat the yellow lines in the same way that it treats the blue lines, so that we don't have to create a square along the yellow line in order to do an extrude for just this part here now. So we can just do finish sketch, and when we choose extrude, we will see that it is possible to highlight only this edge, basically, of the hole there. Now, if you can't manage to highlight it, if you end up highlighting both of them so that you get just a thicker plate, then all you do is hold down your control button on the keyboard, and then you click once more, because then you deselect parts. So then you can remove, if you select too much, then you can remove whatever it is you have selected too much of. So the thickness of this one is supposed to be 6 millimeters. So now we've got that one in place. And let's see. There we are. Just had to orient myself a bit here. Right. Now we're going to create the slot that's going along the backside of this mount, and the slot is going along on the longest side of the mount, and it's going to go straight across. So we can either create a sketch on this side of the part and just create that little outline and extrude it all the way through, making a cut, or we can create a sketch on this side of the part and create the entire length of the slot and then extrude it to the proper thickness. I think the easiest one to do is to actually choose the side here. So we'll create a new sketch, and we'll choose the longest side of the part, and we create a new sketch in it. And then we'll do the rectangle. First off, we'll do project geometry so that we get the yellow lines around the edges of the part. And then we'll do rectangle, but now we don't want to place the center point of the rectangle. So now we want the default option, the one where we place 2 corners of the rectangle. So I'll choose the 2-point rectangle there. I'll zoom in a bit just to make it a bit easier to see. And I'll place one of the corners, I'll connect it to the bottom line of the part. And then I'll move it just a bit upwards here, just to get to see all of the dimensions. And from my view here, when I'm looking at the slot this way, it's supposed to be 3 millimeters high and 5 millimeters wide. So I put in 5 millimeters, I press the tab button, and then I put in 3 millimeters, and I press the tab button. So now we've got the correct dimensions. The only thing we haven't gotten is to place it exactly in the middle of the part. Do you have a question? What the black line in the middle there? Yeah, that's just it basically. I'll just tilt it a bit so you can see it. So I'll just place the rectangle right now, and it has basically found this line inside the part, and it's just telling me that that's also the same location of that line. So that's just why, and that's the only reason why it's showing that black line there. But it's the same as the yellow line. So if you just connect it to it, it's going to go fine. So I'll zoom in a bit again. I'll exit the rectangle function there. And now I'll go up to the constraints up here. And I want the coincident constraint, because I want to find the middle point of the rectangle I just placed, and I want to connect it to the middle point of my part. So I find the middle point by getting the green dot. I select it, and then I find the middle point of the part. And I select that one also. And now I've locked the rectangle into place there. So then I can finish the sketch, because now we need to extrude it. And we'll use the extrude option. I have to zoom in here, because now it wanted to choose all of this side for me. For some reason it hasn't gotten... Let's see. Something's happened in my sketch at least. Let's see. It's fully constrained. So for some reason, Inventor won't recognize my rectangle, but it's fully formed also, so I can't really understand why it won't recognize it. So just to be on the safe side, I'm going to delete my sketch, and I'm just going to quickly recreate it to make sure that I haven't done something incorrectly. Yeah, now I can choose it for some reason. Yeah, so I don't know exactly what went wrong in my first sketch there, but I think it was a glitch on Inventor side that it didn't recognize the rectangle, because I did the exact same thing on this sketch. Yeah, so now I've chosen the rectangle I created, but of course we want to cut it all the way through, so we need to change the option in the middle there over to cutting. So when we click this one, it's going to start cutting instead. But now it's only cutting a certain distance into the parts. So I'll go over to the extents, and I'll do the drop-down menu, and I'll click all, because then it's going to go all the way through this part. Then I click OK, and I'm just going to flip the part around just to double check that it looks okay on the underside, and it does. So now we need to create holes in all four corners, and then I'll use the hole function for the first hole, and I'll use mirror for the rest. So first off, I click the hole function, and I'm going to use the linear placement so that I get to choose where to place it. I choose the surface here, and then I need to give the first reference. You see the red mouse pointer up here has been marked with the whole button has been marked blue. So now I'm going to choose one of the edges here, and it becomes marked red when I choose it. And then I put in the dimension, which was 5 millimeters from both sides. So 5 millimeters from this edge to the center of the hole. And then, without pressing any enter button or OK or anything, I'm just going to go straight on to the next edge, because you can see the next red mouse pointer has been marked with a blue button there. Yes, what's the question? Where I put the hole? Not quite sure what you're asking, but yeah. Oh, the face one, the top one. Yeah, the face one is just the entire surface where I want the hole to start from. So then for the second reference line, I'll choose the other edge. And that one is also supposed to be 5 millimeters. So now the hole has been placed, but I haven't given the proper diameter for the hole. So I need to go up here and change the diameter of the hole. And it's supposed to be 4 millimeters. Once that is done, then we are finished, because we only need a hole to go straight through, and it's supposed to be 4 millimeters and 5 millimeters from each of the edges to the center. So then OK, and we have the hole in place. Now if you want to repeat just doing the hole once more, then you can do a hole on the other corner and then maybe do a mirroring on those two holes afterwards, or you can create all 4 holes if you want to. That's not a big problem. I'm going to do mirrors on this one, so I'm going to mirror this hole over to one side, and then I'm going to mirror those 2 holes over to the other side, just to make it a bit quicker. But in order to mirror in this one, I need to go into my origin folder in the browser tree. Just open it up so that I can see it, because I need to check that I have one plane going through the middle of my part here, and that plane won't help me because that's going below my parts. But this plane will also help me because that one is also going straight through the middle of my parts. So this was sort of the whole point with using the rectangles, where we put them in the center first, and then we hook them up to the center of our coordinate system, because that means that we will have two planes that are going straight through our parts. So now I'll go up to the pattern part of the toolbar, and I'll choose the mirror option. So I'll use mirror. And the feature I'm going to select is only the hole. So I click on the hole there. And then I go over to the window and I make sure that I can select my mirror plane. So it needs to be blue, that button. And then I'll go look at the planes over here. So if I select the YZ plane in this case, I'm going to mirror a hole over on this side. So I'm going to do that one, YZ plane. Then I click OK. And for some reason, when you're mirroring a 3D feature, you don't have to press apply first. You just press OK. But if you're mirroring in a sketch, you have to press apply, because nothing's going to happen if you press OK. So it's a bit inconsistent when they've been programming this stuff, but for some reason they want to do it like that. So then we'll do another mirror feature. And this time, if I try to select the original hole, so if I go to the original hole here, that will only select the original hole that I created. But if I go to the hole that I just mirrored earlier, so if I go and move my mouse pointer over to that one, then it has selected both of the holes, because now it's selecting the mirror operation, and the original hole is a part of the mirror operation. So if I click that one, then I have both holes selected, and then I need to select the correct mirror plane. So then I go over to my browser tree here, and I find the XY plane. And that's going to mirror it over to this side. So I click on that one, and then OK. So then I got all 4 holes on my parts. Then all we need to do is to set the material of the part and save it before we start creating a drawing. So I'll go up to the material. And this one is supposed to be PMMA plastic. So I go down here and I find the PMMA plastic. And we'll see that it turns pretty translucent when we choose it. So PMMA plastic, that is one of the plastic types where you can get it fairly translucent. You can get it almost like glass if you want to, if you polish it enough. So it's a nice one. Then I'll just save my file. This one is called Mount. Then I'll just give people a brief chance to catch up a bit before I continue with the drawing. Right, so we need to get moving on the drawing on this one. So we keep the part up, and we click on the new one, up in the corner there, the new sheet, and we select a new drawing file, iso.idw. And then we're going to place the base view. And I'm going to rotate it a bit, so I want to look at it this way. So I'm going to rotate it to the top there, and I'm also going to rotate it 90 degrees, just to get it in the correct location, so that I'm looking at it this way, and that this is going to be the back side of it, with the slot going horizontally through it. And the scale is way too small. We can't have it that small. We will have loads of troubles putting all of the dimensions on. So we're going to try 2:1. And 2:1 could work, but I think we're going to use 3:1. That looks a bit better. So we'll use 3:1. I'll just move it a bit over to the side here. And now we're going to create two sections out of this one. So we're going to create one section that's going to go horizontally through the parts. So we'll do that one first. So I choose the section option up here. I move it down to approximately the center of the part so that I get this green dot there. Then I move the mouse pointer over to the side a bit, and I place the start of the section line, and I pull it straight across the part. And you can easily see when it snaps to being horizontal, because it's very easy to see it when it's at an angle. It looks a bit funny. So when it's a straight line, it looks a lot better. So I place it there, left click, and then continue. And then I'll put the view up here. So I'll fix a little bit on it afterwards, just to get to show the text properly, the AA text and everything like that. But we'll move around on it afterwards once we've created the second section view. So we'll create a second section view on the base view here. And this time I want to create it in several planes. So I wanted to cut through this hole. I wanted to cut through the middle of the parts. And then I wanted to cut through this hole also. So I'm going to find the center point of the hole up here, and I'm going to pull the mouse pointer upwards until it's a fair distance outside of the part. I'll start my line, and I'm going to pull it down past the hole, but not so far that it's going past the edge here. So I'm going to stop where I'm at this point, and I'm going to click once. Because then I can start moving the mouse pointer over to the middle here. I need to find this green dot on the middle. And I'm going to connect it to the green dot, because then I'm exactly in the middle of the part. And then I'm going to continue to move the mouse pointer past the square in the middle. And I'll place the mouse pointer there again, one click. Then I move it down and I locate the center of the hole over on this side. And I'm going to move it up here so that I get it at a 90-degree angle. Click once more. And now finally I'm going to pull the section line out past the parts. There. So once this is done, I can right click and then do continue. And you can see that the section view has created 90-degree angles here. And since we're looking in from this side, it can't see anything along the lines that are following the line of view. So it's only going to see the vertical lines here. So the horizontal lines aren't going to show on this one. So when I place it, we get a black line going through here, which just signifies that we have this section line going horizontally there. So this horizontal section line is the equivalent of that black line going through the part there. But now we can see a cut through the hole, a cut through the center section, and a cut through a hole on the lower part. So now I need to move it a bit more down just to get some more room on the top one here. Like this. And then we'll place some center lines and center marks before we do a short break. So I'll go to the Annotate toolbar up top. And then I choose the center line function. And in this case, when we're looking at a base view, it's going to be symmetrical, both horizontally and vertically, or else we couldn't have done the double mirroring of the holes. So we create a center line horizontally that's basically hidden by the double A section line. But that one is there in case we decide to remove that section at a later point in time, if we're editing the drawing. We also create, whoops, I forgot to finish this one. So create there, and then the next one, going from top to bottom, because then we also show that we have symmetry going across here. And we'll do the same for our sections here, show that they are symmetrical. Now I'm being sloppy here, I'm not creating my center lines. So create. But for this one, I also want to extend. So I'm going to drag the edge of the center of the symmetry line just to get it to go past here. Then I need to place proper center lines in this sectioned hole and that sectioned hole, because those are cylindrical. So then I use the center line bisector option, because then I can just click on the edges of the hole and it's going to create a perfect center line through it. And now I'm only missing the center marks on the base view. So I go to the center marks up top there, click on that one, and then I mark each of the holes. So then we'll continue after the break with this one. I think we'll do a 10-minute break, just so that we can hopefully get done with the next practice task also. Okay, then we'll continue with the drawing. So we'll start putting in dimensions. And first off, I'm just going to change it to method 1B straight away, so that I get the correct formatting of it. Now, since we have symmetry going both vertically and horizontally on this one, we can give all of our dimensions here across the symmetry line, which makes it a bit easier to place our dimensions. So for an example, from the center of this hole to the center of this hole, I can place one dimension. And then from the outer edge to the other outer edge, we'll place the other dimension. And then if I do the same on this side of the part, so that I get the center of that hole, the center of that hole, and then I get the entire length of the part. The square in the center is going to be dimensioned on the section views instead, so we don't need to put that one into here. So for the square in the center, I'm going to put in 11 millimeters on this side and 15 millimeters there. I could put in typical on those ones, but in this case I think it's a bit clearer if I put the exact dimensions in. So it's going to be a bit tight fit in getting the dimensions into place up top here, but I need to just pull it down a bit afterwards. So I'll move it afterwards instead. So we got the 11 for the hole and 15 for the outside edge. And then we're going to do the dimensions of the slot. So we'll do the width on this one, and we can do the height on that one. So I'll just zoom in a little bit here, and we'll get the width over here. Get it centered there. Then I'll do the height over here. Then I'll do the height up to this point, so that we get the 8 millimeters there. And then I'll also do the height, total height of the parts, so all the way up here. So now the only thing that we haven't put dimensions on yet is the holes. And for the holes we can just use a hole and thread function. And we need to change the formatting to method 1B. And once we've placed it, we can edit it, and we can add in that we have a quantity of 4 holes in it. So then we can just double click the hole note. We go to the beginning, and then we press the quantity note button. And if you created your holes like I did, where you created one original hole and then you mirrored twice to get it, then it's going to show straight off that you have 4 holes. But if you created each hole individually, then you need to edit the quantity note, and you just need to change from showing number of holes in pattern or feature and change it to showing number of like holes in view, because then it's going to count all of the 4 millimeter diameter holes that you can see. So that once it's placed, I have 4 times 4 millimeter diameter holes, and they're going all the way through. Considering that I've put in this information here, the section that we've used here, where we actually used it going over several planes, wasn't really necessary. I could have done a straight section through the middle, because I don't really need to show these holes on the section view. But this was more of a practice in placing in a section view where you get several planes shown. So then I need to move my my top section there a little bit. So this is always a bit difficult. So I'm going to place the name of it a bit closer, and then I'm going to try to just pull the entire view a little bit down. So it's getting a bit tight up here. If we had moved it even closer, it would have been practically not unreadable, but it would have been even more confusing. So ideally, I would have moved the base view here even further down, but if I do that, I'm not going to have room here for my general tolerances. So So now I'll put in the general tolerances. And surface finish. And it's the ISO 2768-1. And on this one, it doesn't say anything, so we're going to use a fine tolerance. And we'll use ISO 2768-2. And we'll use the equivalent of the fine one, which is, I can't quite remember. Which is a capital H. Then we'll do the surface finish symbol. Place that beside the note. And they'll have to remove material on this one. And in this case, we want it to be an extra fine surface. So we'll put in RA 3.2 instead of 6.3. So 3.2 is, they're still going to just use their milling machine to create it, but they're going to use a slightly lower speed when they're moving the tool around, so that it's going to create a nicer surface. We could have written in 0 point something here, and that would have forced them to do it as fine as they could with the milling machine and then polish it afterwards. But in this case, we're just going to leave it at 3.2. So those are like requiring the manufacturer to polish a part is more like if you're creating, for an example, for a subsea camera, and you're creating the port which the camera is going to look through. You want that one to be as translucent as possible. You want it to be as clear as glass to look through, and then you need it to be a very smooth and polished surface. Even though it's created from some sort of plastic which is see-through, you still want the surface to be as if it was glass. So they really have to work on it. So then you would specify polishing and everything in this case. But here we're not going to, it's not going to be necessary to see through it, so we're just going to put it as a fine surface. Then we'll put in the parts list up here. Select one of the views and place it. Then we double click the parts list so that we can start editing it. The first thing we edit is going to the table layout, and we remove the title as usual. Then we go to the column chooser and we remove the selected properties, and we place in the material. There it was. We click OK and OK. So I'll just make it a bit nicer here, all in one line and in the corner. So then I'll just do the break sharp edges note. So 0.2 millimeters by 45 degrees. And I'll move it down in the corner there. So now we just need to fill in the title block. Then we go to the ISO part of the browser tree. We open it up and we edit the field text. And we start filling in. We have the title, amount, put in the student number, the company name, part number since I haven't saved it yet, revision number, checked by, and approved by. and the date of approval. And we just check that we have gotten all of the values in there, and we press OK. So then the drawing is complete in this case, and we'll shortly start on the next practice task. So I'll just save mine, and then I'll start closing it down. And I'll create a new project for the new task. On the H drive. And in my case, in the lecture folder, practice task 6B. And I'll change the name to practice task 6B also. And then finish. Done. And now I'm in the new project. So I'm going to create a new part file. And since I've created a new project, I have to click on the metric folder again. Then the standard in millimeters IPT. So create a new one. And for this task, we are going to create this bracket. And it's a fairly quick 3D modeling. But as you are going to see, it is that as you get more and more experienced in doing this, the 3D models are going to go quicker and quicker, while the two-dimensional technical drawings usually take just about the same amount of time. No matter how quickly you manage to create the 3D model, the 2D drawing still takes time in creating. So we'll start a new sketch. I'll start off at the horizontal plane. I'm going to tilt it this time so I get it the right way around with the top. And I'll create a new rectangle. And I might as well use one rectangle where I define my center, so I lock it in place in the center of my coordinate system here. And what we'll be creating right now is basically, if we're looking at the back side, so we'll be creating this part, this rectangle first off. And that one is going to be, let's see, it's going to be 45 millimeters wide and 75 millimeters tall. Because then we have this one. But before we do anything else, we're going to create one more rectangle, because we want to create this part of the rectangle. So we want this to protrude from it. And then we go to the regular rectangle option, where we are putting in 2 corners of our rectangle. So I'll just zoom in a bit to see it a bit better. And then we'll connect to the first one, just somewhere along the side here. We'll connect the first corner. We'll pull it a bit out here. And according to our dimensions, it's going to be, let's see, 30 millimeters in length. So 30 millimeters. And it's going to be 20 millimeters in height. So we lock those in place. And now I can't really do anything else but just place it. But the thing is now, it's not completely locked into place because I can move it up and down. along the edge here. So I need to give it one more dimension. So I need to give it the dimension from the bottom of the first rectangle to the bottom of the second rectangle. So the dimension option, this line and then that line. And I'm setting that dimension to 15 millimeters. Then I click Finish Sketch. So now we're going to extrude both of these rectangles at once. So we'll use the Extrude option. And we'll choose both of the profiles. And they are supposed to be 10 millimeters. So we'll just leave it at that. Press Enter or OK. And now we've gotten this part plus this one without the rounded edges or anything. So we'll finish off this tap here first off. So we'll do a fillet on it. We choose both edges there. And of course the fillet is not going to have a radius of 2 because we want it to be a complete half circle around there. So it needs to have 10. If you are unsure when you're putting fillets like this into place and your head isn't with you this morning or something like that, you can't really manage to do the math in your head, what you do is just put the width of it and divide by 2, and it's going to place it perfectly in a half circle around there. So that's one of the nicest options in Inventor, the fact that you can just put in your equations and then you don't have to really calculate them in your head. So then we'll use the hole feature to create the hole going through here. But since we now have these nice filleted edges, we have a concentric reference, so we can use the concentric option. And for plane, we'll just select this surface on the part. And for concentric reference, we'll select the fillets that we just created, because then it's going to place the center of our hole in the center of the fillets, of the radius of the fillets. So there, we've got it in a perfect location, and now we just need to set the diameter to 6 millimeters and click OK. So now the only thing we're missing is the top part here that's protruding upwards. Then we'll start a new sketch, and we'll start it on the top of our part. We'll use project geometry. Because right now we're looking at it like this, and we need to create this part that's sticking out. So we create a new rectangle where we're going from corner to corner, and we'll attach one of the corners to one of these corners here. So the first corner we're putting in, we'll attach it to the corner here. Then we'll pull it over to the bottom line. And we're not going to do anything with this dimension because we're going to connect it to this line anyway, so this dimension is going to be set. But this dimension we need to do something with. So the thickness of this part is 8 millimeters. So we need to put in 8 millimeters. And we need to press our tab button again so that we get the padlock on there. And then we can also see, just briefly here, behind the padlock on my dimension, I do have one of the constraint symbols. And the one that's hidden there is the one that says that now I'm connecting it to this line. So if I just click now, I have it all in place, so it's completely locked in there. If I now finish my sketch, I can do an extrusion on this new rectangle there. But we don't just want 10 millimeters up here. We need the full length of it. And the full length is 72 0.5 according to the drawing, but that's the full length going all the way from the bottom to the top. And we already know that we've got 10 millimeters here, so we need to subtract 10 millimeters, because then we get the proper length. So we place that one in. I'm going to zoom out so we can see it. And now we're going to do the exact same thing for this top as we did for this one. So we're going to do fillets around the edge, and then we're going to create a hole using the same center point. So we do our fillets. We choose the edges. But a radius of 10, that's not enough in this case. But we remember we put it to 45 in width, so we can put in 45 divided by 2. Or we can just look at the original drawing and see that it's 22.5 in radius. And then we place it. And then using the hole function, it's going to be very easy to place the new hole. Concentric. On this surface is where we want the hole to start. And using the same center point as the fillets. The diameter of the holes, the hole is 16 millimeters, and press OK. So now the only thing we need to do is to set the material for this one. And the material is supposed to be titanium. So I go into the material and I scroll all the way down and find titanium. And then it becomes a bit more shiny. So now I can save and start to create the drawing. This is a bracket. And then I'll start a new one up in the corner there. New. Go down to the ISO.IDW. And then I'm going to place my base view. And right now I'm looking at it this way. And that's fine by me. I can look at it from that angle. I don't need to flip it or anything like that. But I do want to rotate it 90 degrees this way. So that when I create a projected view, I'm going to get this one sticking up. So I'm going to rotate it 90 degrees that way. And then I'm going to place a projected view over on the side here. Like this. So that we have this one, and then we have that one. But the scale is a bit small. We can't really, it will be very difficult if we put in all of our dimensions here. It's going to be difficult to read because everything is so small. So we need to scale it up a bit. And 2 to 1. We can already see they're jumbled into each other. So if we move the base view over to this side, then we're going to have enough room. But if we increase the scale even more to, for an example, 3 to 1, then there's not going to be enough room on our sheet of paper. So we'll just keep it at 2 to 1. And we'll click OK. And then I have to drag my base view a bit over to the side here. Just to get some room between them. Now, up until now, we have usually been able to place symmetry lines and make use of those in almost all of the parts that we've created. But in this part, that's not possible because we don't have any symmetry at all here. So we're going to start off by putting center marks on our fillets and on our holes. And this was a thing that many of you sort of forgot or probably didn't know in your first submission. It is that when you put a center mark here, it's only telling you where the center of the hole is. You also have to put a center mark on the fillet if you want it to be very clear that you have that both of those are sharing the same center point. Because now we have these long lines, they are showing that the center of the fillet is right here, and then this short line is also showing that we have the center of the hole in the exact same position. So the same happens over on this side. If I make the fillet first here, then we can see that it's missing this line to show where the center of the hole is properly. So if we then just also click the hole, then we get all of it in place. So then we can start placing dimensions, and I'm going to use this edge here, so this side, as my baseline. So I'm going to give my dimensions on this view with regards to this edge and over here. So we're going to use the regular dimensions, switch it to method 1B. Then I'm going to give, first off, the thickness of this part, because we are looking straight at it in here, so we can see the thickness of it. And then I'll give the distance from the edge and over to the center of the hole and the fillet. And instead of now giving the dimension from this side and all the way to the edge, I'll instead just give the radius. And there is one thing that you can do here. If you feel that just giving the radius here, since we have a 22.5 radius here, in order to avoid confusion, it is possible to, before you place it properly, right click, and then you can go to the dimension type option here, and you can actually choose to show the diameter instead of the radius if you want to. So I'll just show that. So if I choose to show the diameter instead, it's also going to show me that the other side basically of the diameter. But that's not really a problem, because now we know that the diameter of this fillet is going to be 45, and it also means that the width of this one is also going to be 45. But it's not a problem in using just the radius there also. So it depends a bit on how you want to interpret your drawing in the most easiest manner. So I'll put the radius in. So now by giving this radius, we know that we have a length of 50 over here, and then it's supposed to be 22.5 for the rest. So we know that combined it's going to be 72.5. We also know that since this fillet is supposed to be 22.5, this part here has to be 45 millimeters. So one thing we can do, just to make completely sure that whoever is reading this drawing doesn't mix up this radius in any way, we can put in the 45 millimeters here. But since it's going to be the fillet that's deciding the exact dimension here, so that if they're creating the fillet and they get a radius of 22.4, they're going to get 44.8 in this dimension. So we can't really put a specific dimension here, but we can give it as a reference dimension with a parenthesis around it, because that's just an extra information basically. So this is the one that is deciding the dimension when they're creating it, and this one is just to make it easier for them to see that 22.5, that's 45. So that's an option to put in there. Then we can also give the dimensions on the other side. So I'll do the same option, that I'll start off on this edge, and I'll move over giving dimensions here. So first off, I'm going to give the thickness. And if you don't get this one where it's aligning the dimension with the one on the other side, you can force it to by moving the mouse pointer over to here so that it ends up becoming red on that one. And then when you move your mouse pointer back, you're going to get these dotted lines. That's putting them in place. Because then if I put this one down here, if I print this one to a sheet of paper and I put a ruler across here, then these dimension lines are going to be exactly on line, unless your printer has done something wrong. So we do the total length also here on the other side. Want to get it in line with the length on the other view. Now we also need to give the length to the center of this one, but giving that down here, it's going to give us a dimension line going all the way across our part, and that's not something we really want. Ideally, we would want all dimension lines to be outside our part. So if sometimes we really do have to place dimension lines inside our parts because it's impossible to show it in any other way. But in this case, if we just place our dimension above our view instead, it's going to look a lot nicer. So if we place it up top here, it's going to be easier to read that one. And we also need to know how far we are to go to get up to the center point from the bottom line. So we'll place this one also. And we'll do the same with this fillet as we did here. We'll just place the radius in, because that's going to give them all they need in order to create it. So radius of 10 there. Then they know that it has to be 20 wide. So the only thing that we're missing now are the two holes. We haven't dimensioned those yet. So we'll use the hole and thread function. We have to change to method 1b. And I place that one there. And this one up here. So now we have all the information needed in order to create this part. And just to give myself a bit more room here for the parts list and everything, I'm just going to push my views a little bit upwards. And if you then select your base view, you have to select your base view and drag that one around. If I try to use my projected view over here, it's not going to move at all. It can only move sideways, because it has to stay in line with the base view. So the only way to move this one upwards is to move the base view a little bit upwards. Like this. So then I have a bit more room above my title box to put in my general tolerances. So I'll put in a text box. The ISO 2768-1. We'll use medium on this one. ISO 2768-2. The equivalent to medium is capital K for the geometric parts. Just move this one into line with the title box, and then we'll create a surface finish symbol. We'll remove material from it, and we'll use the regular one, 6.3, which is a very, it's basically the equivalent of medium when you're machining it. So using a 6.3 surface finish allows them to mostly run their machines at not top speed, but a very high speed, so that they can create them quickly. And that costs less money if you use less time in creating it. Then we'll put in a parts list. And for this one, we are going to add something more than just the material, just to show you how it works. We're also going to add the mass so that we can see how much this one is going to weigh. So we select one of the views and we place the parts list. Double click on the parts list and we'll remove the title. We don't need that one. And we'll go into the column choosers. Remove the default ones. Scroll a bit down and we'll add the material, and then we'll also add the one named mass. We'll click OK. So now we can see that our material, it's titanium, and it's going to weigh 262 grams in this case. It's not a really big piece, so it's not going to weigh that much. But if I now change my material, so you don't need to do this, I'm just going to show you. So if I go in here and I'm going to change my material, maybe I'll use stainless steel instead. And I'll go back to look at my parts list, and suddenly it's doubled in weight. And that's because the density of steel is approximately twice the density of titanium. So then we get twice as heavy piece if we're making it from steel instead of titanium. So that's just to show you that these things, they update automatically if you just use them. So it's a very nice thing to do, especially the logistics department in your company is going to be very happy if they get the mass of everything on the drawings, so that they know exactly what it's going to weigh. So then they just need to add the weight of pallets and whatever else they're using to crates or whatever they're using to package it in. So then it's going to be easy to order transportation for it, and also calculate approximate estimates of what the transportation is going to cost. So put in the notes text box also. Break sharp edges. It's going to be note 1, 0.2 by 45 degrees. Just move it down into the corner. Then I'll fill in the title box, and afterwards I'm going to show you a little bit more that we haven't really done yet. So I'll just quickly fill in the title box so it's done. Title, it's a bracket. Student number, company, the part number since I haven't saved it yet, the revision number, checked by, approved by, and approval date. So then I have everything for my title field. So what we're going to want to put in now is what you can see in the final drawing in the compendium, and that's a small three-dimensional model of our parts, and just show how we put it in here. In this case, the easiest way of doing this is just to create a projected view from one of the views we already have, and just placing it at an angle. So depending on which angle we choose from the original view, it's going to show it in different views. But what I really want to do is to have it shown like this. And with the base view that I have there, I'm not going to get it to be shown like this in any of them. But what I can do then is to create some regular projected views like this one. I can project a couple of views in order to get it to be placed in the correct position, because I want it to be placed like this in my drawing, or outside my drawing rather, because then I can create a projected view that's going to look like this. So what I do is, outside my drawing here, I'm going to place a new projected view that looks exactly like this one. This is just a temporary one, so I'm going to delete it afterwards. So I place that one there, create. I'm going to zoom a bit more out just so that we see. And what I'm going to do now is I'm going to rotate it so that it's going to be like this, because then I can create another projected view and get it up like this. That means I will be able to create the 3D model in the correct position that I want it. So in order to rotate a view like this, since it's easy to rotate it when we're placing the base view, because then we are just we can use that view box, the view cube, and just rotate it however we want to. But in order to rotate the view that we've already placed, we right click on it and we go down here until we find the rotate option. So we go down and we see that we can rotate it. And what this one does is it's telling me in the two buttons here if I want to rotate it clockwise or counterclockwise. In this case, I'm just going to use clockwise. It doesn't really matter. I'm just going to rotate it 90 degrees anyway. And the default here is that you're going to choose an edge, and then it's going to rotate it, in this case clockwise, until that edge becomes horizontal. So if I choose this edge, which is vertical, it's going to rotate it clockwise until that edge becomes horizontal. Another option is to give an angle to it, so that you can write in just directly 90 degrees if you want it to be rotated at. But it's very easy to use the edge option. So I'm just going to click on this edge, and it's going to be rotated 90 degrees until it's in the correct position. Then I click OK. And I'm going to create another projected view. Place it up here. So now I've gotten it in my correct position for getting the 3D view that I want. And these are called isometric views because they are placed at a 30-degree angle when they are tilted. So I go to my newest view up here, and I create another projected view. And instead of pulling it directly to the side, I pull it also a little bit downwards, because then I get the view that I want there. I can in fact just place it more or less where I want it to, over here. Click create. And it's way too huge now, but that's fine, we can fix that afterwards. Because these projected views that we placed at 90-degree angles from our base view, those are connected to the base view. So if I want to move this one up or down, I have to move the base view. If I want to move this one to the sides, I will have to move this view to one of the sides. So they are connected to each other. And they're also connected to each other by scale. So if I want to change the scale of any of these three views here, I have to change the scale of the base view. But this one, it's not connected to any of the others. So this one I can change the scale of without affecting any of the others. So if I double click on this isometric view, I can set it to a different scale. So we'll try 1:1 first. That's a bit too big still. So we'll do 2:1. No, 1:2 I mean. That's small enough that I can just put it in here, and you're going to get a fair idea of how this part is going to look once it's done. But also, if you want to, you can choose this option up here, which says shaded, and that's going to color it in so that it's not just black and white lines. It's going to be a color in there also. So you click on shaded also just to get it to show properly, and then we get it like this. And if you have set the color of this part, for an example, to be red, it's supposed to be painted after it's been made and painted and become red. So if you've in your 3D model it looks red, then it's going to look red here also. So it's going to be shaded in the same color as your 3D model. But now we have suddenly a couple of views here that we don't need anymore. We've gotten this one into place. We don't need these. So all we need to do is click on the first one we set out, because this one is connected to it. So if I delete this one, the top one is also going to be deleted. So I right-click on it, and I go to the delete option. Once I click delete, it asks me, it's showing me with red on this one, are you sure you want to delete this one? Because it's also going to delete that one. And yeah, I'm sure. So I click OK. And then they're gone. So I can zoom in a bit and just nicely place this isometric view in the corner there. And usually, if this is a drawing that's just going to be sent to your manufacturer and they're just going to create it, there's no point in putting in this isometric view. Because the machinists that create these stuff, they're used to looking at these drawings, and they form a picture in their head of how this is going to look afterwards. They don't need this to help them. But if you have non-technical personnel that's going to look at this drawing, you're going to show it to them. Maybe there's some sales personnel involved. They're going to sell this object to customers and stuff. And especially if you're going to show it to customers, it's nice to have a small 3D view of the item, so that it's easier for the customers to see what it is. So that was all for today. We managed to finish both practice task 5 and 6. So next week we'll start on 7, and there we have 3 parts and an assembly that we're going to create, and that's going to be nice. Since we have a 4-hour lecture next week, we hopefully will manage to do all of it so that we'll create the assembly properly and everything.